Good morning everyone. Myself Khushi Banerjee. The subject name is Electronic Devices and the subject code is AC301. So in the last classes we have already understood what is atomic model, how does the electron move from one orbit to another orbit, how the energy bands are being formed. Now in this class we will study about what are the various types of Fermi level. That is the Fermi level, it is the state, that is how many states will exist at given energy level. In this the equation it is denoted by Fe equal to 1 by 1 plus e to the power E minus Ef by kT. Here Ef it is the Fermi energy level, K is the Boltzmann constant and T is the absolute temperature, and Fe it is the probability of existence of any state. Now for this graph, when we consider E greater than Ef for any temperature T equal to 0, we find that the probability is equal to 0. Similarly, for the same equation, if we find that E less than Ef for T equal to 0, we find that the probability Fe equal to 1. So in this way, we get a step function for the probability Fermi direct distribution curve. Now as we increase the value of temperature to 300 degrees, we can see that there is a curve, that is few of the states have been moved away above the Fermi level. If we increase the temperature more, we can see that more number of carriers move above the Fermi level. Now let us move to the various types of semiconductors. According to the conductivity of the semiconductors or doping of the semiconductors, it is basically classified into two types, that is the intrinsic semiconductor and extrinsic semiconductor. The extrinsic semiconductor, it is further classified into two types, that is the N-type semiconductor and the P-type semiconductor. Now what do we mean by an intrinsic semiconductor? Intrinsic semiconductor are basically the pure form of semiconductor without any doping. The semiconductor material which we generally consider are the silicon and germanium. While the extrinsic semiconductor N-type, it is formed due to doping, while the P-type, it is also formed due to doping. In this diagram we can see there is an intrinsic semiconductor. The intrinsic semiconductor, it is a pure form of semiconductor which is made up of pure silicon and germanium. At the room temperature, we know that there is no free electron or no free hole, that is the number of electron is equal to the number of holes. Now for extrinsic semiconductor, when we add any impurity or doping to the pure form of semiconductor, it becomes an extrinsic semiconductor. That is, without breaking up of covalent bond, we can increase the number of charge carriers by increasing the doping concentration. Now what is the difference between an intrinsic and extrinsic semiconductor? We will see that. In intrinsic semiconductor, it is pure form of semiconductor, while the extrinsic semiconductor is the semiconductor which is done by doping. In the intrinsic semiconductor, the number of electron is equal to the number of hole, while the extrinsic semiconductor, on depending upon the doping, that is if it is doped with a trivalent impurity, we will get number of holes as the majority carrier, and if it is doped with a pentavalent impurity, we get electron as the majority carrier. Now in case of intrinsic semiconductor, the Fermi level lies in the middle of the valence band and the conduction band, while in the extrinsic semiconductor, the Fermi level depends upon the doping. That is, for N-type semiconductor, the Fermi level moves towards the conduction band, while for P-type, the Fermi level moves towards that of the valence band. Now for making P-type semiconductor, it is doped with a trivalent impurity, for example gallium. The gallium has 3 valence electrons which makes covalent bond with the adjacent semiconducting atom, while the fourth, which is the vacancy of the electron, will create a free hole. That is, therefore a trivalent impurity has a tendency to accept an electron, therefore it becomes, in this, the majority carrier are the hole, while in this case the minority carrier are the electron. Now in this way we can see that here a boron is being doped, which is also a trivalent impurity, which has created a hole as a majority charge carrier. Similarly, for N-type semiconductor, it has 5 valence electron, like pentavalent impurity which has 5 valence electron. So the fifth electron, it acts as a extra electron which increases the charge carrier, due to which the majority charge carrier for N-type impurity, it is the electron, while the minority carrier are the hole or N type of semiconductor. Here we can see that phosphorus is being doped with silicon. So of these 5 valence electron of phosphorus, 4 electron form bond with the covalent atom with the neighboring atom, while the fifth electron it acts as the free electron. Thank you all.